All right, so this time we are looking at functions, as equations, or you could call this function notation if you wanted to. So basically, I've got three functions defined up here, and down here, this is function notation, and it's telling us what number to plug in for x. So it's telling us the input here in the parentheses, right? So this is function notation, and what it tells us is that we need to go to the f function, so up here, and plug in 5 for the x. All right, so it's like we're plugging in a 5 here and plugging in a 5 there. But this is the only side that we really care about. So it's just evaluating a function is what this is called. So it's 2, and then instead of an x, we're putting a 5 minus 1. Okay, and then you just evaluate it. 2 times 5 is 10. 10 minus 1 is 9. Okay, so that is f of 5. So when you input 5, you get 9 back. All right, so for g of 2, we're going to go to the g function and replace that x with a 2. So we got a 2 squared and then minus 5. All right, 2 squared, that's 2 times 2, so 4. And then minus 5 will give us negative 1. All right, h of negative 3, so we'll go to the h function and plug in negative 3 for x. So we got negative 4, and then we're replacing the x with a negative 3, and then plus 3. All right, so negative 4 times negative 3, that is 12, and then 12 plus 3, 15. That's it. So these are pretty straightforward. They tell you what function you're dealing with, and they also tell you what the input is for x, and you just plug that in. That's basically it. Now, the reason that these are functions is because every input goes to exactly one output. So like when we plugged in 5 for x, we got 9, and we will always get 9, right? There's never going to come a day where we plug in 5 for x here and this doesn't work out to 9. All right, so that input, or each input, is always going to give us one output. If we plugged in 2 for x and we got something besides negative 1 here, that would mean that it isn't a function. But it's always going to work. It'll always work. All right, let's see. Let's try g of negative 4. So I'm doing this one because a lot of kids will do this part wrong. So if you plug in negative 4 for x, a lot of students will do this right here. They'll say negative 4 squared, but what it needs to be is negative 4 in parentheses squared, right? And minus 5. See, if you had did negative 4 squared like that, this would be negative 16. But if you do it like this, the right way, it's actually positive 16. All right, so you get 16 minus 5 equals 11. Okay. Here we've got h of 2 plus h of negative 1. So we got to do basically 2 evaluations and then add them together. All right, so h of 2 is going to be negative 4 times 2 plus 3. And then h of negative 1 is negative 4 times negative 1 plus 3. And then don't forget we're adding them, so there's got to be a plus sign here. All right, so if you wanted to, you could just evaluate this and then evaluate that, and then add them together. Let's see here. This is negative 8. Negative 8 plus 3 is going to be negative 5, plus sign. This is going to be positive 4 because you got two negatives. And plus 3 is 7. And the negative 5 plus 7 is 2. Okay. Let's see here. We got g of 3 minus f of 4. Let's just plug that in. G of 3. All right, so 3 squared. 3 squared is 9. And then 9 minus 5 is 4. So g of 3 is going to be 4. And then minus. All right, then next we'll do f of 4. So we're plugging in 4 for x. 2 times 4 is 8, and then 8 minus 1 is 7. Oh, and then we'll just subtract those two. 4 minus 7 is -3. And that's all.